And remember your groups you're going to be in the next week.
Oh, I'm on this side. You're going to be on this side.
This will be group 1, Lisa's group is group 2.
Are we roughly equal? I'm going to put you off with Wendy as well. Okay, and where did he go?
Grab that around. Uh-huh. Keep on driving. Hey, everybody. Shotgun. How are y'all? Great. Good. I was kind of about, I don't know much about this. Yeah. And then I'll start, once I get a better feel for what you guys are interested in, I'll start.
Here on Mars Social, so in anticipation of
This is a curiosity visit. Okay.
Very interesting.
Okay. Well, these are the space exploration vehicles, but first generation. We call it SEV. These are crew rovers. So the Curiosity, as you guys know, is a robotic rover, purely robotic. This is a robot, but we tell the astronaut that it's also a rover. So we envision this really being a dual-purpose machine. Sometimes think of it as a space car, the kind of place the crew would use to get around on the surface. And other times it would be a robot that would maybe go to the next place they want or scout, do a lot of things. It's really built more in the moon phase with the idea of think of this as two different things. There's a chassis which is ability to have wheels on Mars, or higher orbit or an asteroid or any other space destination. Probably replace this mobility, real mobility with a different kind of mobility. The concept is what you have to do in the top half with place for a crew to live and work out of for relatively short periods, 3 days, 7 days, 2 weeks. Some people think that they could do a month there. I keep thinking, I think I could do a month there, but I'm not properly motivated, right? So imagine being on Mars, right? Can you do a month in a small place like this? On Mars, right? So the key thing is, I certainly wouldn't want to do it here in Houston in the summer. On Mars, it would be great. So there's live and work out. On the back end, we have soup ports. And think of soup ports as an update on the airlock concept. The airlock. I'm not sure how much you guys know about how things work on the station. But on the station, the crew want to go from inside station to the outside station. So IVA, we call it EVA. It takes them a number of hours. And I'm a launch technology geologist, but it's all about getting the flight chemistry kind of changing the flight chemistry slowly. That you don't get nitrogen bubbles in the blood or anything. The concept here is to run some compression differently in both the suits and the cabin. We use a less compression. Typically, space station is 14 psi, which is pretty close to the atmosphere here. The suits run at 4 psi. So it takes them a while to get this time. So the idea is if you rip up to around 2 psi difference, you can just get in and out without the previous period. So the idea is, we're going to take the cabin, inside the cabin, into the suit, the amount of time it really takes to go through, make sure your seat system's working, make sure you don't have any leak jacks. We think that could be as short as 10 minutes. Let's come around here, we'll let people kind of take a peek inside as well. I think probably just the other message, this is really an R&D vehicle, it's not a flight vehicle, this vehicle would not go to space. potential. That's really because the way we concept and decided to sort of focus on the kind of things that a spacecraft would need. Important things like trying to drive out every ounce of mass, and to drive out every watt of power, and to try to make sure the volume is perfect, and make sure that it just never fails. Those things you got to have on space. But the idea here is really understand the features you might want to kind of be able to see what can work out as opposed to build a spacecraft. You want to do that like motion. And you know, the big thing is what electric vehicles, so I can think that this kind of technology, the battery, the regenerative braking, the by-wire systems, will translate well back into the course. We think there's a lot of technology out of this to transfer down to I said I was going to listen to the question, I just started talking. I apologize for that. Any questions before we go overhead the site?
When you guys actually take it out, you're driving it around out wherever, do you have places here near JSC where you can take it with like a Mars terrain or something?
Well, we have not around JSC here on JSC. We have a very small test site, kind of, I don't know, it's about half a kilometer from here now, a couple hundred yards. It takes us 5 to 10 minutes to drive there. Okay. We have a Mars yard. It is maybe 100 yards, 500 yards, maybe not even quite that. We have a small hill, what I call it the biggest hill in Houston. It's a small hill. I grew up in Colorado, but it's the biggest hill in Houston. And then we have also a small lunar yard that's more shaped like the lunar stuff. So raised, helping create
Right, we're bringing you another group, and we're going to take this group and ship off with Wendy. So it's some more cool stuff, I know. But
Thank you.
We've got another group that's going to come. The other half.
About some of the different analog missions that we work on. We have one that's in an underwater laboratory off the coast of Key Largo. We'll send crew members down there to live and work for 2 weeks at a time. We just finished one in Hawaii where we were testing for a payload that planned to go to the moon to drill and do, we call it recycling, kind of moving off the land. We're searching for water and ice. If you guys want to take any of these materials, you can. What we're doing here is typically our desert rat. But this year we're just calling it RAT. We're doing it here instead of in the desert.
Can you hold that for just a second? It's going.
Space exploration vehicle. And we just finished our dry runs that we were training the crew. We're going to have them at the end of the month living and working in here for 2 weeks. We have 4 crew members, 2 males and 2 females. And they'll take turns living for 3 nights at a time in here. And while they're in here, they're doing simulations. We're doing asteroid simulations. And up here we have in that window is our simulated deep space habitat. We'll have a crew member stationed in there. We have a virtual reality laboratory on the 2nd floor. We'll have a crew member in there doing virtual reality as extracurricular activity where they're tied into the simulation over here where our space exploration vehicle pilots will be kind of like they're hovering over the surface of the asteroid and they're interacting with the astronaut that's on PDA. Yeah, so it's all integrated. Yeah. If you guys come this way, we'll get you over the side. This is really detailed our mission operations for our it's kind of like secret mission control. So but we also coordinate with mission control.
Do what? Yep. Huh? SSRMS. Hey, do you want to hold this and get what's going on?
So if you go on here, nasa.gov/exploration, you can find it. So you follow it for 2 weeks. We're going to have a mission.
So here we are, looking at the Phobos, one of Mars' moons. The imagery we have is not terribly detailed. This probably isn't at all what it looks like, but it's something to go by, right?
Yep.
So we've got an out the window front here. We have side port windows as well. We are floating over a site where we put some traffic cones just to have something to look at when you start up. I've already pitched away from those though, so we're gonna pitch up here and have a look at Mars from its own moon. So yes.
Oh, let's go.
Wow.
So there you have it.
Okay.
The red planet himself.
The external thrusters, or it's the propulsion to move this around?
They are, yes. There are 16 thrusters on this model, I think. Don't quote me on that.
Okay.
Not certain. But there are a bunch of thrusters. They're all at the base. It's on what they call the sled, which is what the vehicle is mounted on.
Okay.
And so we have all sorts of fancy algorithms to determine which thrusters to fire and how long to push you in a certain direction, right? When you're on the hand controller, you say, I want to go straight, or I want to go up, or I want to, pitch forwards. But you don't say, fire jets 1, 7, and 8 for 2.5 seconds.
Yeah.
Humans can't do that. So we have some algorithm that sorts out what jets have to fire, in what order, and for how long. And actually, on Phobos, it takes a lot of thrusting up to keep crashing into the surface. It's so big, it's got enough gravity to pull you into it. So if you're not constantly correcting for that, you'll just eventually start bouncing along the surface. You're not always firing upwards. And we have modes that can do that for you. Position and attitude hold will say, keep me where I am, right?
Yeah.
Do whatever it takes.
Yeah.
And so then we have algorithms that'll crunch the numbers and decide what you need to do to stay there.
Wow.
But that burns a lot of fuel, right?
Yeah.
And so usually you glide around in a free floating mode. Then you can go wherever you want, spin around, look things. There's not too terribly much to look at out here.
Yeah.
We haven't put any high fidelity rocks or any particular features to look at because we're not running any studies currently with the Mars configuration.
Okay.
But at least we do have the basic geography and a nice shot of Mars. That's perfect.
Right.
You guys got any questions? There's all sorts of fancy control panel stuff here and various views you can look at.
Wow.
We've got a rangefinder attached here so you can point at the surface and see how far away you are from things.
Gee whiz.
We actually have this guy is a free-floating camera that's attached to the vehicle.
Oh, that's cool.
Yeah, so if you wanted to get an external view, right, because you can't look at your own vehicle from inside of it. But if you had a free-floating camera, you could stand out there and turn around and look at it. Then you certainly could. And he is right here. So now I actually sent him off. You can barely see him out the port window, that little ball on the left there. And that's where he is. And he's looking back at us so we can get a view of ourselves.
That's cool.
And our terrible attitude with respect to the surface right now.
Yeah. So is this basically a test bed to develop all these technologies, or is this something that is really going to go to Phobos or wherever?
This is absolutely a test bed right now. Its original purpose was to determine the feasibility of these sorts of missions, right? Let's design a vehicle and put a control system on there and simulate an asteroid and see if we can actually go fly the vehicle around it, right? Can we come up with a control system that's intuitive or easy enough, right? It's to test out all the physics and the challenges that might be crashing into the surface soon here. I neglected to maintain my upward motion there, but I'm fighting it, right? I think we might be okay. You can see my downward rate is slowly coming to zero.
Pull it out
I think we might be safe here. Yes. But this is largely a test bed. Because we can iterate through hundreds of designs in here without ever building something in the real world, which costs $1 billion.
Right.
So if you crash in a sim or if you make a horrible design decision in a sim, you've wasted some time.
Okay, we're ready for that too.
We're dialed up to 1600.
That's pretty cool.
Back from Mars.
That is the MRMPF. That's the Earth version of the robotic arm on the station. Long, and that's the shoulder joints are actually ginormous because of the amount of force that we have gravity compared to light. Operation light, you can extend the weight out. So you can see that 1 pound at 50 feet, that's 50 foot-pounds. The thing can hold up to 200. So it holds several thousand foot-pounds. It's a lot of torque. So you end up with big brakes and big motors on the thing. Hydraulic driven. What used to be here? The thing on the end there, that's going to be here, that's what's called latching end effector. That used to go and grapple on pictures. That's where you actually have the little pin that comes out, a little T-bar thing that you can line and go grapple. Inside of there is actually wire snares that fit around so when they get into the snare, they'll pull those tight. Pull the through that. Soft glass, soft on it. So they extracted it.
So would that be the apparatus that the dragon was exactly the ISS?
Yes, it's exactly, that's the same thing. The latching end effector is exactly the same.
Okay.
The only thing you can't do is get under that. Any other questions?
Where are these items constructed at?
This one was actually going with the prime contract.
You guys got any questions?
Well,
That I might be able to answer?
well, this is supposed to be some kind of thing about Phobos things.
This is a simulation of Phobos.
Right.
Supposed to be over Phobos.
Hey, Mark.
Accurately positioned for Mars. We model all of the orbital dynamics and all that stuff, so there's certainly gravity that I have to constantly fight with so I don't go careening into the surface. I nearly did that with the last group that was in here. I was neglecting my elevation, talking too much.
Oh.
We almost crashed. We're okay now. But you can see I've got range rate data here, and my downward range rate is slowly going more negative because that gravity is pulling me down, and I'm not fighting it, right? I'm just free floating. So eventually I'll go smashing into the surface and bouncing around. That's what would happen.
Going to get these
Computer stuff they used to model all this and take
What specifically are you asking about?
like what kind of system you use with one
Well,
giant big mainframe type thing that you have it all, or is
Actually,
it,
we're running Linux is the operating system we have, and we're using. You just got a bunch of Dells, right? To drive this is actually quite a feat. There are, I think, 8 computers running this, and then a master computer that makes sure they're all synchronized and all that. But the sim just runs on a single computer out there on the side that we're plugged into the computer with. So they're not. I mean, they're 8-core, 2.5 gigahertz processors, but it's not like a supercomputer. We don't have a giant mainframe right now. But you can run this on your laptop. You have a sufficient laptop. Back, because people, we've got offices all over the place, and you gotta be able to run it everywhere. So it's by no means a simple sim, but it's not so terrible. You need a supercomputer.
Gotcha. Cool. Thank you very much.
You bet. Thanks for coming.
It's coming out of
I may hit a button.
Still going.
Who is the gentleman that's sitting inside?